Dr. Laura Jakubowski, and in this video, I am going to demonstrate how to do the determination of an unknown compound using a mixed melting point technique. The items we will need are our unknown sample. The unknown sample for this demonstration could be one of two things. It can either be cinnamic acid or it could be urea. The equipment we will need are a mortar and pestle. As an alternative, if you do not have that, you may use a watch glass and a test tube. We will also need several pieces of weighing paper. We will need 3 capillary tubes. And for melting point determination, be sure that you have capillary tubes which are sealed at one end. We are also going to need a glass tube which is open at both ends. As an alternative to this, you can use a pipette which has had the narrow end cut off. We are also going to need a balance, a digital balance, some weighing boats, and our melting point apparatus. For this video, I am going to use the Stewart SMP10 model. To start, I am going to load my capillary tube with the unknown sample. This has to be ground to a fine powder first, so I'm going to put a bit of it in the mortar and pestle. You don't need much, just what I'll call a pea-sized amount. You want to grind it until you get a very fine powder. So now to load the capillary tube, it is easier to transfer this powder to a piece of weighing paper. So I'm going to tap it out onto the weighing paper. Now I will take my capillary tube, and having the open end pointed down, I am going to push it down into the powdered sample. The goal is to load the capillary tube with a height of about 5 millimeters. As an estimate, that is about half the width of your finger. So right now I have the sample loaded, but it is at the top of the capillary tube. We need to move it to the bottom. So I will use this glass tube. I'm going to set the bottom on the desk, and I'm going to drop the capillary tube down into the glass tube. You will see it will bounce several times. And in doing so, it has moved the sample from the top of the capillary tube down to the bottom. This capillary tube is now ready to do melting point analysis. Since this compound was unknown, we will set up this instrument to rapidly go through a temperature range in order to catch at what point this sample might melt. First, I will turn on the instrument. We are able to set the plateau. This is the temperature to which the instrument will rapidly heat. I'm going to set a high plateau temperature of 180 degrees Celsius. To change that setting, I'm going to hold the plateau set button down. And I'm going to use the up arrow to change it to the 180 degree setting. Okay, the plateau has been set to 180 degrees. I'm going to load my sample in the capillary tube into the aluminum block here, which is what will be heating up. I will look through the magnifying lens to be sure my sample is in the correct position. My sample is in place. I have set my plateau temperature. I'm going to start the instrument. After pushing the start button, you can see the heating light on the instrument has turned on. And now the instrument will rapidly heat until it reaches the plateau set temperature. Since I do not know the melting point of this compound, I am going to need to keep an eye on it throughout this entire process. And I will note at which temperature it begins to melt. Okay, my sample has begun to melt. I noted the temperature had been at 136 degrees Celsius. So I'm going to stop the instrument. And next, I know that my unknown could be one of two compounds, urea and cinnamic acid. Both of these compounds have a melting point close to 133 degrees Celsius. This is also close to what I just observed. Note that determining the melting point in this way with the very rapid heating rate is just an approximation. So I've confirmed my unknown does have a melting point near one of these two compounds. Next, in order to confirm which of the compounds it is, I'm going to mix my unknown in a 1-to-1 ratio with each of the known compounds. To do this more precisely, I am going to weigh about 0.1 grams of each my unknown and the known compound, and I will combine them and grind them together. So I will turn on my balance. I will use a weighing boat for this. And I will take approximately 0.1 grams of my unknown. Okay, I have 0.12 grams. That is close to the 0.1 value. This time to do the grinding, I will use the watch glass and test tube technique. So I'm going to place the 0.1 grams of my unknown onto the watch glass. Next, I'm going to mix this first with the cinnamic acid. So I'm going to take approximately 0.1 grams of this. I have taken 0.13 grams. Next, I will put this on the same watch glass as my unknown had been. And I'm going to use the bottom end of the test tube to grind and mix the two samples together. You want to aim to have these samples be as mixed together as you can manage. Next, I'm going to transfer my sample, my mixed sample, from the watch glass onto a piece of weighing paper. Just through tapping, I will transfer. Now I will take a clean capillary tube, and again, putting the open side down into the powder, I'm aiming to get a height of the sample of about 5 millimeters into the capillary tube. That appears to be about 5 millimeters. Now I will tap it down using the glass tube. So this is a mix between our unknown compound and the cinnamic acid. I'm going to place these two together into an empty beaker and set this to the side. Next, we need to mix our unknown with the urea in a 1-to-1 ratio. But before doing so, we need to clean the watch glass and test tube, which we had used for the previous mixture. So I have here a container for organic waste. I will dust off as much of the powder as I can into the waste beaker. And then I will use a bit of acetone to continue cleaning. I will weigh out approximately 0.1 grams of my unknown. I will take a weighing boat to the balance, tare, and next tap in approximately 0.1 grams of the unknown. I have taken 0.14 grams. I will transfer this onto the watch glass. Next, I need approximately 0.1 grams of the known urea. I will put a fresh weigh boat, tare, and take approximately 0.1 grams. I have taken 0.18 grams. I might add a little of this to the waste container just to have closer to the 0.1 value. Okay, this is 0.16. The unknown had been 0.14. That is close enough to a 1-to-1 ratio. So I will add this now to the watch glass. Now I'm going to grind and mix on the watch glass, being sure to mix the two components as efficiently as possible, at the same time as grinding it to a fine powder. Next, I'm going to transfer this onto a piece of weighing paper in order to better load the capillary tube. So I will tap from the watch glass onto the weighing paper. Again, I'm taking the capillary tube open side down, and I'm going to push it down into the sample, aiming to get a height of about 0.5 millimeters into the tube. I am pushing the capillary tube down into the powder until I get a height of about 0.5 millimeters into the capillary tube. And I'm going to drop it down into the long glass tube to pack it into the bottom of the capillary tube. The sample is now ready in the capillary tube. So we have our two mixtures now. In this capillary tube, we have a 1-to-1 mixture of our unknown compound with the cinnamic acid. In this capillary tube, we have a 1-to-1 mixture of our unknown compound with the urea. The next step would be to take the melting point of these two mixtures. A mixed sample will have a lower melting point than the known melting point. So with this example, we know the melting point of both urea and cinnamic acid to be about 133 degrees Celsius. Upon taking the melting point of each, we will look for that. If our mixture melts at that temperature of 133, that is a good indication that our unknown could be the compound that it was mixed with. If our melting point is much lower than the expected 133 degrees, then that's indication that our unknown compound was not the compound that it had been mixed with. The next steps will be to determine the melting point of each of these, and you will use that information to help possibly identify which of these compounds could have matched with the unknown. I will mention one last thing. If both melting points end up being much lower than the expected 133 degrees, then that could be an indication that our unknown was not either of these compounds, and you would need to move on and try mixing with a different compound.